Let us check the next number, that is problem number 16. Let me read out the question first. Three resistances, each of magnitude R, are connected in the form of an equilateral triangle of side A. The combination is placed in a magnetic field. B is equal to B naught e power minus lambda t. That is the equation corresponding to that magnetic field in which we are placing that combination of three resistances connected in the form of an equilateral triangle perpendicular to the plane, he said. The induced current in the circuit is given by, that is the question. And four options are provided to us. First option is a square lambda b naught by 2 root 3 r whole multiplied by e power minus lambda t. Second option is given a square lambda b naught by 4 root 3 r whole multiplied by e power minus lambda t. And third option is given this way, a square b naught by 4 lambda root 3 r whole multiplied by e power minus lambda t. And fourth option is given this way, a square b naught r by 4 lambda root 3 whole multiplied by e power minus lambda t. Out of all the four options, the correct option is the second option, that is B, which of course has been given as a square lambda b naught by 4 root 3 r whole multiplied by e power minus lambda t. That is the correct option. Okay, let us check how do we get that particular option for this particular problem, that is 16 I am talking. Let us first of all check here. There is an equilateral triangle shaped combination of three resistances. Each resistor is R, he said, and the magnetic field is perpendicularly into the board. That is the direction what has been mentioned over here. So the magnetic field is represented by intos like this. So all of you can understand the direction is now into the board over here, into the paper when you just draw the same circuit on your notebook. That is the concept. And what is this magnetic field represented by? This magnetic field in the problem has been represented by a small equation. B is equal to B naught e power minus lambda t. That is the equation by means of which the magnetic field applied over here is represented. Fine. What is the question he is asking? Question is very simple. What is induced current in the circuit? That induced current when we want, let us first of all check what is the magnetic flux. Magnetic flux of course can be written as BA, in fact BA cos theta. But in this particular case the maximum value over here is BA, since cos theta is 1. So no need for us to take that one separately over here, B into A. What is this value of B given? You look at B naught e power minus lambda t into the side length of this particular equilateral triangle is already mentioned in the problem as A. Then what will be the area of this triangle now? Half into A into root 3A by 2. Simply speaking, half BH formula, base into height, nothing else. So this is actually the formula for magnetic flux. So you can understand this one. This now becomes B naught e power minus lambda t whole multiplied by root 3 a square by 4. If you can directly remember this one for an equilateral triangle, the area is root 3a square by 4, that is fine. Otherwise, at least you can remember this way, that is also one of the methods. The moment we have come across the value of magnetic flux produced in the system, what will now be the induced EMF? Induced EMF is minus d phi by dt. That negative sign, of course, we used to consider according to the conservation law of energy which has been given to us by Lenz law, minus d phi by dt. What is this value now? You can directly take this one here, root 3 a square by 4, take it as it is, b naught you take it out, d by dt of e power minus lambda t. In fact, this now becomes lambda e power minus lambda t, that too with a negative sign. So that negative sign and this negative sign, they multiply to give positive value. So what do you get here? You will be getting directly root 3 a square by 4 into b naught into lambda e power minus lambda t. You can get this value as minus lambda e power minus lambda t. That only I have written directly here. This is EMF. But we don't want this value here. He is asking us to calculate what is the induced current in the system. Induced current, when you want, current I is equal to E by effective resistance. You can certainly understand all the three resistances are connected in series. Then what would be the effective value of resistance? It becomes 3R. So directly I can write E by 3R. Now what is the value of E? Already we have calculated. Substitute that value here. 1 by 3R into this root 3 a square b naught lambda e power minus lambda t whole over 4. That is the case. Now of course you can cut this root 3 here root 3 times. Now what is left over? You simply check that one. This becomes 4 root 3 r in the denominator. And what is now left over there? You can take b naught a square lambda divided by 4 root 3 r whole multiplied by e power minus lambda t. That is the value what I have got ultimately from this. When you just look at this particular value, which option that is coinciding with this? The second option you look into, a square lambda b naught divided by 4 root 3 r into e power minus lambda t. The second option is exactly the same whatever I have got by calculation. So we can say directly the answer for this particular problem 16 is B. So only point one should understand from this entire calculation is this: while calculating current, its induced EMF by resistance we write. No doubt absolutely in that. But which resistance is to be taken up? That should be effective resistance in the entire system. By any chance if you take only R there of 1, then you will not get the right option there. So it is effective resistance. Since all of them are connected in series, that effective value of resistance now becomes 3R as such. So this is actually the calculated value for this particular problem. To calculate the value of induced current, we have adopted this methodology. So first we have estimated what is the value of magnetic flux. Then we have taken that induced EMF, which is the rate of change of magnetic flux, that to negative rate of change we used to call it, and that we have calculated. Therefrom we have estimated what is the amount of induced current across the total system, that is in the circuit. This is problem number 16 what we have here. So correct answer for this one is B, that is the correct option. Let us check the next number, that's problem number 17. Let me read out. A non-conducting ring having charge Q uniformly distributed over its circumference is placed on a rough horizontal surface. A vertical time varying magnetic field, the magnetic field which is varying with respect to time, a vertical time varying magnetic field B is equal to 4t square is switched on at time t is equal to 0. Mass of the ring is capital M and its radius is given capital R. The ring starts rotating after 2 seconds. The coefficient of friction between the ring and the table is how much? This is a problem from electromagnetic induction. It is linked with the concept of friction over here. And what are the 4 options given? Look at the first option, 4qmr by g. And second option, 2qmr by g. And third option, 8qr by mg, that is weight of course mg. And fourth option, qr by 2mg. That is the concept. One thing you should understand here, a non-conducting ring having a charge Q, and of course he has given placed in a magnetic field, charge given Q, mass given M, radius given R. These are the values. In addition, he has mentioned over here the value of magnetic field, which is a time varying field, that is given B is equal to 4t square. So that is varying according to this particular equation with respect to time. And after 2 seconds it has started rotating. That is the concept. First of all, you should understand here, when can that particular ring rotate? What is the condition for the ring to rotate? Condition is, we people are having charge on the ring. Definitely there will be a force due to electric field acting over there. Whatever is the force due to electric field, if the force is equal to the force of friction that is acting on the ring, then only it is possible for the ring to start rotating. So what is the condition for the ring to rotate? First of all, one should understand that in fact is directly taken up in terms of torque, clockwise torque, anti-clockwise torque. Now since the distances are equal, okay, we can take in terms of forces over here. Whenever the force due to electric field is equal to the force of friction that is acting on the ring, then only that ring starts rotating. So what should I write now? Since Q being the charge, Q times E will now be the electric field, the force due to electric field acting on the ring. That now should be equal to mu times mg, which is nothing other than the force of friction that is acting on the body. Acting on the body means, okay, he has given the mass of that body as capital M. So I can write the same thing this way, mu times mg. That is the case. But out of this, when we want the value of mu, the one and only one value which we have to estimate is going to be E. That is nothing other than electric field intensity or intensity of electric field or field strength, whatever you call it. In this problem, if you look at carefully, that value has not been provided to us. Due to that, what we have to do? We have to link up this magnetic field with that electric intensity. How? We know there is a simple equation, integral E dot dl, which is nothing other than the magnitude of d phi by dt. So if you can understand this particular relation, the resultant should be very simple. So how to write this value now? It can be written as surface area into the value of phi is equal to B dot A. That is the case. So we can write this one dB by dt. S into dB by dt, that we people can write from this equation. And what else we have to take here? B is given 4t square. So directly you can calculate what is the differential value of that. But next concept over here is, what is this value of S here? What is that value of S now? You can now write this way, E times L. E dot dl, that of course directly we can write E dl is nothing other than E times L. L is integral dl over here. That is of course known to us. That now is going to be, what is S here now? Pi r square into d by dt of this value 4t square. So what is this value you are getting ultimately? Pi r square as it is. This now becomes 8t. But at the same time we can write E times what is actually integral dl, that is L. L is of course of the ring. Ring now the circumference is 2 pi r. Circumference we can write it as 2 pi r. That is equal to pi r square times 8t. Now one pi I can cancel, one r I can cancel. What is the value of electric field intensity now? You just can write this one, this 2 also cancels here 4 times. So 4 RT. That is what we people have got as far as electric field that is concerned. The moment electric field strength, that is in terms of radius of the system, that ring, and time, it is 4 RT. Write this value here. So what we just want in this case, we know certainly Q times E must now be equal to mu times mg. That is actually the condition for the ring to rotate. So what exactly the concept you should understand is, for the ring to rotate, what is the condition here? The condition is that the force due to electric field and force of friction are supposed to be equal. That is a condition. Now we can write this value of E over there. So Q times 4 RT is equal to mu times mg. This implies mu value will now be Q times 4 RT by mg. But of course he has mentioned over here after what time the ring has started rotating from its position of rest. He has mentioned the value after 2 seconds the ring starts rotating. So we can say when t is equal to 2 seconds. What is the value of mu now? This now becomes 8. So you can write 8 QR by mg. Look at those options given there. First option is mentioned as 4qmr by g. I have already mentioned. Second one 2qmr by g. Third one is 8qr by mg. That is the correct option for us. And fourth option, you need not look into that one at all when you have got already the correct option over here. It's of course qr by 2mg given. So what is the correct option here? Mu is equal to 8qr by mg. That is the concept. Now which is given as the third option over here. Therefore, answer for this particular problem becomes C now. Only thing you should understand is this condition. What is the condition? For that ring which has been placed in a magnetic field, time varying magnetic field, rotate. When can it rotate? At least the force that is acting due to electric field is equivalent to the force of friction. At least that is a minimum force. Then only there is a possibility for that ring to come into motion. As long as frictional force is dominating there, the ring will never rotate. It remains at rest only. That is the concept one should understand from this particular case. So the correct answer for this particular question 17 is answer C, what I have written here as 8qr by mg, according to the 4 options which are being provided to us in that problem as such. This is problem number 17. Let us work out the next problem, that is 18. The magnetic field in a region is given by B bar is equal to B naught x by a k cap. That k cap is given to tell us that the magnetic field is along z axis, that too along positive z axis. That is the point. A square loop of side D is placed with its edges along x and y axis. The loop is moved with constant velocity. V bar is equal to V naught I. That means it is moving along x axis. When time is 1 second, the induced EMF in the loop is how much? Once again he has given 4 options. The very first option says B naught V naught D. Second option is B naught V naught D square by 2A. And third option says B naught V naught D square by A square. And fourth option is B naught V naught D square by A. In fact, the correct option for this particular problem 18 is D. The fourth option is the correct option for us. Let us now check what are the values given first. The magnetic field in a region is given by B bar is equal to B naught x by a k cap. So one can directly understand that x over there may be the thickness of that particular body like. A square loop of side D is placed with its edges along x and y axis. So you can certainly understand this way. If I take this as x axis, this as y axis, this is the square loop what he is talking about. So one edge is right on x axis and one edge is right on y axis. That's what he is talking about. And he has given us its side length is given as D. This is the one. In addition to that, he has mentioned here that the magnetic field is along positive z axis. He has mentioned that one. That particular dot indicates the direction of magnetic field is perpendicularly outward. That is the concept we have to understand. And what else he has given you? The velocity after 1 second, whatever the time he is talking about, is V naught I. That means it is moving right along x-axis. That is the case. Now what is the induced EMF in the loop? That is the concept. So we just have to go for two different values here. What is the initial magnetic flux first of all linked with that particular coil? Initial magnetic flux. I just write the same concept. What will now be the initial magnetic flux linked with the square loop or the coil, whatever he is talking about. A square loop, he said. Fine. That I can write it as phi I. The initial magnetic flux that is linked with that coil. Of course, we people can write this one as phi I. How do you get that? Integral d phi I. Integral d phi I, that's nothing other than phi is BA. We know that point very well. So we can rewrite that one integral B naught x over A into the d into dx. But in between the limits what? This of course when t is equal to 0 we people are talking about. Therefore 0 to the value of d we people can write. So this is the value of phi I, that is initial magnetic flux that is linked with that loop which has been given in the form of a square. So when I just take up this one, this now becomes d square by 2. Then of course you people can write directly x square by 2 means that now becomes d cube here. So what will be this value now? Phi I now becomes B naught by A into d. Of course I can take x dx integration is x square by 2. That now becomes d square into d cube by 2. You get like that. That is the first value what I can treat that one as initial magnetic flux that is linked with that square loop what has been given in the problem as such. And when time is 1 second, it has started moving with certain velocity. Then what can we write now? In this particular case, what will now be the final magnetic flux that is linked once again with the loop? That of course is a square loop obviously. This we should take when t is equal to 1 second. Okay, afterwards also you can write that t is equal to 1, there is no harm in that. But what will now be the value of phi final? As usual we can go for d phi final. But in between the limits what? Actually when time is t, the present distance becomes Vt. Already d is there. In addition to this length it used to travel. So I should write this one Vt plus d. So d already is the distance. Velocity into time is also distance. So from initial distance to final distance we people are just integrating in between. Final distance after what time? 1 second. Initial distance when t is 0. Now this is integral between Vt to Vt plus d. What is that equation again? B naught into x by a into d into dx. You directly can rewrite the same equation this way. Once again you take b naught by a out. This now becomes x dx, x square by 2. X square by 2 means, can't you just understand b naught d if I take by a into this now becomes x square by 2 between the limits vt and vt plus d. Observe this particular point carefully, that's all. So what we can write now from this? It's b naught d by a into vt plus d whole square by 2 minus vt whole square by 2. That anyhow you can simplify, there's nothing wrong in that. What ultimately we want from this calculation? He is simply asking you what is the induced EMF in the loop. So ultimately we can say the induced value of EMF. Induced EMF is nothing other than minus d phi by dt. In other words, I can write the same this way: phi final minus phi initial by t. What is that time to be taken here? 1 second. And even here also you can put the value of t as 1. You can simplify the total lot. You will be getting the value of phi final. This already we have got phi initial. This is my second equation, and phi final minus phi initial by t, which is going to be 1 second. If you simplify that one, you will be getting directly b naught v naught d square by a, you will be getting directly. That means what is this value equal to? It is similar to the fourth option which has been mentioned over there. I just have skipped off one small step here. What is that? This minus this I just have to write, that's all. That anyhow you can definitely make it, it's not a big task. When once you know in between what limits we have to integrate that one, it is a simple, very simple problem. And why we people are taking up this way? When t is 0 to t is 1. That means initial distance is this and final distance is d plus vt. That is the concept what one just has to understand. And t being 1, you put that value, simplify, take the difference by t. Once again t being 1, you will be getting this value. Means what? The correct answer for this particular question is the fourth option, which is D, according to the 4 options provided to us in this problem. So the method what you people have to adopt, I hope all of you might have followed. First you calculate what is the initial magnetic flux linked with that loop when time taken is 0. After 1 second he is talking, it started moving like, therefore in time t is 1, what is the corresponding value? You think it over. Take the difference, you get d phi by t, that is the induced EMF, that is what actually he is asking for. The moment you take this phi 2 minus phi 1, automatically that negative sign gets cancelled. You will be getting positive value only, don't worry about that. So this is actually the problem number 18 what we have in this order as such. Let us check the next number, that's problem number 19. A solenoid has 2000 turns wound over a length of 0.3 meter. The area of its cross section is 1.2 into 10 to the power minus 3 meter square. Around its central portion, another coil of 300 turns is wound. If an initial current of 2 ampere in the solenoid is reversed in 0.25 seconds, the EMF induced in the coil is how much? Not in the solenoid, he is talking about the other coil which has been wound around in the middle of that entire solenoid. Across that one, what is the induced EMF? He is asking you to calculate. 4 options are mentioned. First option is 48 millivolt and second option is 48 kilovolt. Number is same but units are different. Third option is 6 into 10 to the power minus 4 volt and fourth option is 6 into 10 to the power minus 2, that is kilovolt. So the correct option for this one is the very first option, which is 48 millivolt. That is the correct option. Now what you people should understand first of all is, there is a solenoid over here, like it has been wound round this way, and here right in the middle there is another coil which has been wound around. That is what actually he is talking about. But one thing you can understand in this case also, already we people have discussed this type of a concept earlier, but not same model, same problem or same model problem like. But this concept we have taken up earlier. Whenever the field is reversed or the current is reversed, or whenever the coil has been rotated by 180 degrees, in all the 3 different concepts, we people used to consider the value of phi to be double its value. What for we people can better understand? Initial value of phi, if I take plus phi. When you reverse the direction, the same quantity of phi you will be finding, same amount you will be finding, same magnitude you will be finding, but in the opposite way. Whenever we consider the change in magnetic flux there, it is minus phi again. So that now becomes 2 times phi with a negative sign. That negative sign automatically cancels over there because we have minus d phi by dt, the formula for induced EMF. So whenever he is talking once again in this problem also, the current initially is 2 ampere in the solenoid, that is reversed in 0.25 seconds. Then what is going to be the EMF induced in the coil? That is the concept. What is the general formula for induced EMF? You can directly take up in terms of mutual induction. We have to go for. What is in terms of mutual induction? What is mutual induction first of all? M is equal to E by di by dt. E for EMF. Di by dt in this particular concept is nothing other than rate of change of current over there. So if you take the cross multiplied value of this one, you will be getting the value of E, which is induced EMF, is now going to be the value of mutual induction or coefficient of mutual inductance into di by dt, which I to be taken up over here. So it is E is equal to M into di by dt. How many times we people have to write this one? Twice we have to write. What is the reason? Already I have given you, the current has been reversed. So we need to take this one 2 times. Which I to be taken? That is primary current, what is considered there. So basic formula for working out this particular problem is this: twice m into dIP by dt. IP, that stands for the primary value of current. The variation in primary value of current will be getting there. That is the concept. Now the next step, how can we directly get the value of m? We know in fact n phi is equal to mi. Therefore, m can be written this way: m is equal to phi by I. I am just coming back from the main equation. What is that phi? Phi across the secondary coil. And what is that I? That is across the primary coil. So m is phi secondary by I primary. That is the value of m. Fine. What next do we want? What is the value of phi secondary? We need to know what is that magnetic flux across the secondary coil which has been wound right in the middle over there. So what we can write? Phi secondary is equal to NBA. What is what out of that one once again? N is the number of secondary turns. So number of secondary turns he has given. A is area of the secondary turns. We can write NBA, that is phi s. So if you write this one here and divide by IP, you be getting m. That m you can substitute it over here. Fine. But how to get the value of B now? B is nothing other than the magnetic induction that is being produced over there. Magnetic induction in which coil? The primary coil, what has been taken up as having 2000 turns over there. So what is that value of B now? Mu naught n into I. So we can write this value: B is equal to mu naught n into I primary. What is this n now? N is nothing other than number of turns per unit length. What is the number of turns he has given you there? 2000 turns per unit length, that is 0.3, into what is the total current that is passing through that one? It is 2 ampere. So I think you might have understood all the 4 separate steps now. You calculate first of all the value of B. That value you substitute it here, you will be getting the value of phi s. That value you substitute it here once again, you will be getting m. Then you substitute that value of m over here to calculate the value of induced EMF. So problem is no doubt a little lengthy. In 4 different steps we people are writing, this is the value of B first, then the value of phi s, then the value of m, then the value of E. Now ultimately if you just substitute the values and finalize this value here, you will be getting 48 millivolt as the correct option for this. So probably you might have understood the direct concept behind. So let us take the magnetic induction that is produced in the or generated in the first coil, primary coil. Mu naught Ni. That is the general formula. N is the number of turns per unit length. Because it is a solenoid, this is the formula. Calculating this, substitute that one here, you will be getting phi s. After getting this phi s, yes, given area of cross section also, everything of course he has given you there. After getting phi s, substitute that one here, you will be getting M. After getting M, substitute that one here, you will be getting the induced EMF. So this link up, if you can understand, it's not a difficult problem, but certainly a little lengthy by nature. So correct option, what you can expect for this one is 48 millivolt, and which is the in coincidence with the very first option which has been given to us. So the correct option for this one is 48 millivolt as such. That is for problem number 19. Let us work out the next number, that is problem number 20. A coil of some internal resistance small r behaves like an inductance. When it is connected in series with R1, that means a resistance R1, the time constant is found to be tau 1. And when it is connected in series with another resistance R2, then the time constant is found to be tau 2. The inductance of the coil is how much? That is actually the question. Four options are mentioned once again. Tau 1, tau 2 into R1 minus R2 by small r tau 2 minus tau 1. That is the first option. And second option is tau 2 minus tau 1 by tau 1 tau 2 into R1 minus R2. That is the second option. Coming to the third, it's R1 minus R2 by tau 2 minus tau 1. And fourth option, it's tau 2 minus tau 1 by R1 minus R2. Correct option for this one is the first one, that is tau 1 tau 2 into R1 minus R2 whole divided by tau 2 minus tau 1. But what we people should understand out of that one first of all is, this is an LR circuit. What is going to be the time constant in the case of LR circuit? Time constant in LR circuit, tau is equal to L by R. That R in this case is to be taken as R effective. So what can I write according to this? Tau 1 will now be L by R1 plus R. That's my first equation. Exactly in the same manner, the second time constant he has given, tau 2 is now L by R2 plus R. That's my second equation. And what is the question he is asking? Question is, what is the value of L? He is asking. And in all the four options, if you look carefully, we don't have the small letter r anywhere. So simply you can understand we have to eliminate the value of r there, nothing else. So from the first equation, you can write that R1 plus R is equal to L upon tau 1. Then what will be R? It is L by tau 1 minus R1. This value I directly will substitute it here. So therefore I can directly write this way, tau 2 into R2 plus this R, L by tau 1 minus R1 is equal to L. I have cross multiplied, that's all. Now you can directly understand here, this if I multiply, that directly I can take up R2 plus L by tau 1 minus R1 is equal to L by tau 2. Now in all these options is giving R1 minus R2. So you bring this R1 and R2 this side and get that L by tau 2 this side. L into 1 by tau 1 minus 1 by tau 2 is equal to R1 minus R2. Now you can directly write L becomes R1 minus R2 whole divided by this value tau 2 minus tau 1, tau 2 minus tau 1 by tau 1 tau 2. So what you can directly write from this one? This implies L is equal to first time constant into second time constant into R1 minus R2, the difference of the resistances, divided by second time constant minus first time constant. This is ultimate result after completing the calculation. So this result is exactly in coincidence with the first option which has been mentioned there, that is tau 1 tau 2 into R1 minus R2 by tau 2 minus tau 1. So directly you can say the correct answer for this particular question is A. Only thing you should recollect once again to mind is that the time constant in an LR circuit, whether it is in growth system or whether it is in decaying, like whatever be the case, when the current is growing there or decaying there, hardly that matters. You will be getting time constant remaining same, that is L by R, the formula I am talking about. The value is not same there. Remember that L by R is the formula for time constant. If you can understand that, this problem is not a very big one. This has been one of the JEE problems long back. That's what you people have to remember. So this is, the answer is A for this, and this is problem number 20 what we are having in this order. Now the question number 21. A condenser in series with a resistor is connected through a switch to a battery of negligible internal resistance and having an EMF of 12 volt. 1 second after closing this switch, the condenser is found to have a potential difference of 6 volt. The time constant of the system is how much? And 4 options once again. First option is 2 seconds. Second option is 1 by log 2 to the base E. Third option log 2 to the base E. And fourth option log of 1 by 2 to the base E. And correct option is the second one, which of course is 1 by log 2 to the base E as such. So that is the correct option for 21st question. Let us once again check. It is CR circuit, capacitor and resistance combination. In that combination, we know how to just write the charge that is growing in the system in the form of a formula. We know well Q is equal to Q naught into 1 minus e power, right, T by tau with a negative sign. But one thing you should understand here, the value of Q can now be written as CV. This now can be written as CV naught into 1 minus e power T by tau. And of course, C getting cancelled, we are left with V by V naught is equal to 1 minus e power minus T by tau. What are the values of V and V naught given? Look at first. Initial value of EMF is 12 volt given. After 1 second, the voltage is dropped down to 6 volt he gave. So what we can understand from this one directly is this V is now 6 and this V naught is 12. 1 minus e power minus T by tau. This of course is 1 over 2. Therefrom I can write e power minus T by tau is equal to 1 by 2. Now if you simplify this one, e power T by tau is equal to 2 I can write. If you reciprocate this one directly, 1 by e power T by tau is 1 by 2. This is the equation. What I can write from this? T over tau is log of 2 to the base E. So if you look at this, what is the value of tau is the question. It is T by log 2 to the base e. And what is the value of T given? You look at in the problem. After 1 second, closing the switch after 1 second is talking. So T must be 1. So it is 1 by log of 2 to the base e. That actually is the concept. So which option is true in this particular case of CR circuit? It is 1 by log 2 to the base e. It is of course similar to the second option given out of the 4 options. So you can understand it's 1 by log 2 to the base e. That is the case. In fact, log 2 to the base e value everybody knows, 0.693. That also he can give, but here he has given you the answer directly in the same format. That's 1 by log 2 to the base e. That is the concept. So you can understand this one. It's 1 over log of 2 to the base e. That is the correct option what one has to understand. So the correct answer for 21st problem is B according to our calculation. That is problem 21 now. Now check the next number, problem number 22. An inductor of L is 100 millihenry, a resistor R is 100 ohm, and a battery of EMF E, also 100 volt, are initially connected in series as shown. After a long time, the battery is disconnected after short circuiting the points A and B. The current in the circuit 1 millisecond after the short circuiting is how much? So 4 options. First option is 1 over E ampere, and second option is E ampere, third option is 0.1 ampere, and fourth option is 1 ampere. The correct answer for this one is the very first option, which is 1 over E ampere as such. He is just giving us a small circuit here. There is an inductance coil, there is a resistor over here, and there is a cell which has been connected over here of EMF 100 volt. This is what has been given first. And inductance value he has given 100 millihenry and resistance 100 ohm. So this is 100 millihenry. The resistance over here is 100 ohm as such. These two are the points what he is talking about in the problem. One is point A he gave, one is point B he gave. Removing this cell, he has just short circuited the system. That means it directly has connected these points without having the cell in between. That is what he is talking about. In fact, we know very well when L is this, R is this, E value is this. When battery is on, you can understand the very first one. When battery is on, then what will be the current across? No doubt E by R. It's 100 over 100. That now becomes 1 ampere. Simple. But what he said is, after a long time, battery is disconnected. That means one should understand first of all, when the battery is on, current grows from minimum to maximum. How much its maximum value? It's 1 ampere. So you can understand when the battery is on, current grows from minimum to, that is minimum is 0, to maximum value. What is the maximum value over here? That is 1 ampere as calculated by us. Now after a long time, when this battery is disconnected and these 2 points are short circuited, then whatever the current that has grown in the circuit earlier, now slowly and in an exponential way, it now starts decaying. We can certainly understand decay of current is going to take place in such case from the maximum value. So when decay of current is to be taken up, what is the general equation we go for? I is equal to I naught e power minus R by L into T. In fact, minus T by tau. Tau is going to be L by R. So R by L into T. When can we come across this situation? This is the situation when the cell is disconnected. When the cell is disconnected and points A and B are short circuited. That is the case we have to go for. And we all know what is the value of I naught now. It is 1. So straight away we can now calculate what is the required value. The current in the circuit 1 millisecond after short circuiting it. That means you calculate this way. Therefore, I is equal to I naught is 1 e power minus R by L into T. What is the value of R by L? You calculate first. Or R by L into T directly we can calculate. What is resistance given? 100. L given 100 millihenry. Time given 1 millisecond later. So it is 10 power minus 3 second later. So you can cut this one, 100 gets cancelled. Altogether you are getting this total value as 1. So what is it we are getting? This implies I is equal to e power minus 1. Direct this value we have got it as 1. E power minus 1. Can't you now rewrite the same as 1 by e, please? So what will now be the current after 1 millisecond time, after short circuiting the points A and B, removing the cell? That is a question he is asking. So after removing the cell, short circuiting the system, this is going to be the current now. It is 1 by E, which is the very first option for us in this problem. So the first option, in the sense A itself is correct there, 1 by E in ampere. So we can write directly the unit as ampere over here, because all the values are given in SI units over there. Then automatically current also should be considered in SI units. So the correct answer for this 22nd problem is going to be 1 by E ampere, which is the first option according to the 4 options provided to us. Okay, problem number 23 now. A 0.4 meter long straight conductor moves in a magnetic field of magnetic induction 0.9 Weber per meter square with a velocity of 7 meter per second. The EMF induced in the conductor under the condition when it is maximum is how much? The options are given this way. First option is 2 volt, second option is 2.52 volt, and third option is 5.22 volt, and fourth option is given as 3.5 volt. The correct option for this particular problem is 2.52 volt, which is the second option out of the given 4 options. Observe first of all, this is one more problem which is based on motional EMF of a that is produced across the ends of a body. What is he talking, you see? There is a rod like this, a body, a uniform body like this. This now is just moving this way with a velocity v. That's what has been given, and the length of this particular rod is given as L. A straight conductor he is talking. That straight conductor's length is given as 0.4 meter, fine. But look at carefully, when it is just going across that way, making an angle theta. And he has mentioned very clearly, this is the direction of the applied external magnetic field on that conductor. And we all know this particular notation into, when we are writing, the direction of the magnetic field is into the board, perpendicular, and perpendicularly it's going into or entering into, that's the one. Now when it is going with a velocity v, what will be its component along this direction? V cos theta. But what will be the component along this direction now? V sin theta. So in place of v, we have to go for that formula. And what is the induced EMF he is asking you? EMF is no doubt d phi by dt. Ultimately, what is it we people are going to get if you simplify this one? B L V sin theta. That is the formula. In fact, V becomes V sin theta. That's all is the only point. Now you can understand, for E to be maximum, for E to be maximum, what is the condition? Sin theta should become 1. So what is this E maximum? That is what he is asking, B, L, V now. So all the values he has provided you. What is B? You check it, it's 0.9. What is the length of that conductor given? You just look at 0.4 meter. No need even for you to convert the values also. He has given like that. And with what velocity was it moving? It's 7 meter per second. So all the three values are known to you. This BLV, if you just multiply, you will be getting 2.52 volt as such. That is the one. So this of course becomes 0.36. 0.36 into 7. Exactly 2.52 volt you will be getting, which of course is coinciding with the second option given in the problem as such. So only thing you should understand is, since it is moving, making an angle theta with the length of the conductor, we need to take the component of velocity across this particular direction. That is vertical component we have to go for, and it is V sin theta. According to that we have to adopt the formula. And sin theta should become 1 because he is mentioning the condition. Under the condition when it is maximum, the EMF we just want. That means maximum EMF only you just want there. That is nothing other than BLV. Straight away we can go for. So that is problem number 23, of which the correct answer is B, which is 2.52 volt as such. Let us check the problem number 24. A square loop of side A placed in a magnetic field as shown. The magnetic field varies as B is equal to alpha minus beta t. The resultant EMF of battery when its open circuit potential difference across the terminals was found to be E is how much? A battery is in open circuit and its EMF when it is connected in an open circuit is E. That's what he is mentioning. And what are the 4 options given? First option is E minus alpha square beta. Second option is alpha E minus A square beta by 2. It is in fact not alpha, it is A. Third option E by 2 minus A square beta, and fourth option E minus A square beta by 2. So correct option for this particular problem is the fourth one. It's E minus A square beta by 2. That is the concept. What is the figure he has mentioned? You look at. He is just talking about a square loop. Square loop has been given this way. Right? The square loop is just connected this way once again like this, and across that one he has just connected a cell like this. This is the one what he is talking. This is the loop ultimately. And what he has done was, he has taken a line which just is going to be the diagonal of it. And what he has technically he has done in this particular problem is, this upper half he has just placed in an external magnetic field. That means you can certainly understand lower half has nothing to do with that applied external magnetic field as such. Only the upper half is in the magnetic field. What is the value of that magnetic induction he has given you? B is equal to alpha minus beta t. That is the equation by means of which this magnetic field has been given like or represented. This is the one. And what is the concept he is talking about? He said the EMF of the cell is already given as E. In fact, you can understand when the cell is in open circuit, whatever the PD that is existing across the terminals of the cell, that only we officially call it as EMF. So EMF is given as E, fine. Now what he wants is resultant EMF of the battery. Resultant EMF we just want to have. So what you have to do? Simply you calculate what is the induced EMF in the upper half of that square loop of side A. This side length is also given as A here. This is A. And this side length also is A, because it is a square. That is what actually we have to go for. And what is that general calculation for induced EMF? Minus d phi by dt general. That is the general formula. Every one of us we know. But when we talk about the value over here of phi, how to just write this one now? It's minus d by dt of BA. Because you can all understand phi can be written as BA, BA cos theta actually. The maximum value in this particular case is to be taken as BA. Now you rewrite the same this way, A you bring it out, it's minus A d by dt of B. What is that value of B that is given? You see, alpha minus beta t. So you be getting this one as minus A into minus beta. D by dt of alpha minus beta t is after all minus beta. So this now becomes A times beta. And one should understand here, A is the area which is being influenced by the external magnetic field applied on the loop. Had the total loop be inside the magnetic field, we would have taken area as L square there. But in this particular case, half of the loop only is inside the magnetic field. Very, very clearly is mentioning that one in the figure. So what we should write in place of area there? A is equal to, but of course we can write A is equal to A square by 2. For a square loop, area comes to be A square, side square. But it is half of that one only which is inside the magnetic field, or which is being influenced by the magnetic field that is applied on that loop. So what can we write now? Therefore, this induced EMF now becomes A square beta by 2. So you can certainly understand A square beta by 2 is the induced EMF, which of course is going to be in the reverse order that's being produced. Therefore, what is the net EMF of the cell? That now becomes earlier EMF minus A square beta by. Look at this particular option over there. The fourth option is exactly the same. It is E minus A square beta by 2. That is going to be the net EMF across the cell. That's what he is asking you. The resultant EMF of the battery when its open circuit potential difference across the terminals was found to be E. Open circuit potential difference means nothing other than EMF. When its EMF is E, what is its present value? Present value will certainly be reduced because of this induction. Due to induced EMF, the total value of EMF will be dropped down now. By how much? We have calculated, that is this. So what is the effective value now? That is E minus A square beta by 2, which now is going to be the resultant or net EMF across the cell. That is what he is asking us. So the correct answer for this particular problem is D. The fourth option is in coincidence with the calculated value in this problem. So for 24th problem, correct option is going to be D as such.